Hi, I'm Lisa and this is Threshold in China. Today we are going to share some exciting tech innovations and announcements that happened in China last week. Traces of an ancient alien protoplanet may have been lurking deep inside Earth for billions of years since the planet's birth. A new study from Caltech in the US and the Shanghai Astronomical Observatory suggests parts of a Mars-sized rock called Theia may still be buried in Earth's lower mantle, around 2,900 kilometers beneath the surface. Theia is the name given to the hypothetical protoplanet believed to have collided with the proto-Earth around 4.5 billion years ago during Earth's formation. And there is a hypothesis that suggests this giant impact threw debris into space, which eventually formed the Moon. Over the centuries, various other moon formation theories have been proposed. The fission hypothesis suggests that part of the early molten Earth was spun off into space due to rapid rotation, later cooling to form the Moon. The capture hypothesis proposed the Moon was captured into Earth's orbit as it flew nearby. However, the different compositions of the Earth and the Moon contradicts these ideas, so the giant impact hypothesis is more plausible. But concrete evidence of Theia's existence has yet to be found. Previous research had shown that seismic waves traveled very slowly through the anomalies, which are the size of two continents in the lower mantle, 2,900 kilometers below the surface. In this study, computer simulations indicate that they were 2 to 3.5% denser than the surrounding mantle. The researchers speculate the high-density material may be the remains of buried Theia mantle material, which was retained deep in the primordial Earth as a result of the colossal collision. These high-density Theia remnants sank across tens of kilometers to lower regions of the mantle, where they accumulated to form denser clumps above the Earth's core, which remains to this day. According to the research, these formations are expected to have a higher concentration of iron compared to the typical mantle rock found on Earth. Additionally, their chemical compositions may bear resemblance to volcanic rocks found on the Moon. This study backs the lunar impact hypothesis, and it may just tell us how the Earth and the Moon came about. How many of us have indulged in high-calorie foods? Now, scientists have discovered why it is so hard to stop eating them. According to a new study from Zhejiang University School of Medicine, high-fat diets can potentially cause a group of appetite-suppressing brain cells to go on strike, leading to uncontrolled eating. The researchers focused on GABAergic neurons in a brain region called the VOPAG. These VOPAG neurons act to prevent overeating. When the brain senses hunger signals, the VOPAG neurons respond to supervised food intake. Some studies show that even when people lose weight by changing diet and lifestyle, their weight often rebounds within 5 years. So what do high-calorie food do to our brains? To find out, the researchers fed one group of mice a high-fat diet, while a controlled group received a standard food. After 6 to 8 weeks, the mice in the high-fat diet group showed a 25% increase in body weight. What surprised the researchers was that the GABAergic neurons of the mice were strongly inhibited after about a week of feeding the high-calorie food. That means even before we see a change in weight, the brain is already affected, with activities in these regulatory neurons dropping dramatically. Without the self-regulation of the brain cells, the mice became addicted to food and soon became obese. To further understand the molecular changes associated with obesity and potential targets for intervention, the researchers performed single-nucleus RNA sequencing. They identified CACNA2D1 as a gene of particular interest, suggesting its potential involvement in obesity-related mechanisms. Through the transgenic adenovirus technology, they increased the expression of the CACNA2D1 gene in the VOPAG GABAergic cells of the obese mice. Their food intake is reduced, and at the same time, its body weight and body fat levels have also declined. This makes CACNA2D1 a potential target for the treatment of recalcitrant obesity as well. The team leader, Professor Wang Hao, also suggested the possibility to screen for potential weight loss drugs. The Washington Post published a group of disturbing satellite images that shows just how immense the people in the Gaza Strip are suffering. Using advanced nightlight remote sensing technology, the image provides a comprehensive analysis of the data-stricken region. It is a collaboration between the UNOSAT and Wuhan University. It highlights a steady decline in the power supply across the Gaza Strip since the outbreak of the conflict. As of 21st of October, an alarming 80% of the buildings in Gaza experienced power outages, with the few remaining structures primarily being vital healthcare institutions. Among Gaza's 5 provinces, Rafah province exhibits relatively lower power losses compared to other areas. The team carried out detailed correlation analysis between geographic and satellite data to assess damage to key infrastructures such as schools, hospitals, and refugee camps. This provided direct and accurate information to support international relief efforts. Remote sensing technology is used to obtain ground images to provide disaster information. Nightlight remote sensing has unique advantages over traditional remote sensing in 2 ways. First, it can provide larger images of disaster distribution under the same condition, allowing macro assessment. Second, traditional remote sensing can only detect damage during the day. Nightlight remote sensing obviously overcomes this limitation. Earlier this year, the Wuhan team and UNOSAT also collaborated to assess the earthquake-stricken areas in Turkey and identify significant reduction in nighttime light, particularly in these locations. In the aftermath of a disaster, electricity serves as a lifeline for hospitals, sustaining the lives of patients and newborns. Lives could be saved using nightlight remote sensing to understand the power situation and map the nearest power lines. And that is all for today's Threshold. We hope you like this news section on science and technology in China. As usual, we welcome your feedback and thoughts.